Hi everyone, welcome to my channel Axiom Programming Basics, and today we're going to talk about logical operators, and in this video we're going to also see how the logical operators are used. So the logical operators are mainly AND, OR, and NOT, which is also a negation. So before we dive in, we need to take a look at the truth table, how the logical operators actually work, or you can say the inner mechanism of logical operators. So before we go to the truth table, we need to know that in C++, 1 represents true and 0 represents false. So as you can see over here, true and true will give you a true value, and the rest of the comparison will give you a false, which is kind of inverted, the opposite for OR comparison. So as you can see, any OR comparison is true except for false or false. Now if you negate a true value, that will give you a false, and if you negate a false value, that will give you a true. And then this is also a really important part, order of precedence. So over here you can see a simple algebra, A or B and C, and this will be evaluated like A or B and C will be evaluated in a whole. So there is another thing which you need to know, is called a short circuit evaluation, which C++ uses. So as you can see over here, if we have a true value, then it will short circuit itself, because if we have a true value, the result over here for OR comparison is true anyhow you slice it. So if you have a true value for OR comparison, you have a true for the result. So over here we can say we don't need to evaluate for the second value if we have a true value in the first execution. But if we have a false value, then we need to see if the second value is true. This is what C++ follows. And for AND comparison, if we have a true value, then we need to also see if the second value is false. But if we have a false value, we don't need to evaluate it, because if we have a false value at the first execution, the result will be false. So this is what the C++ inner mechanism of truth table is, and this is what C++ follows when it is having a short circuit evaluation. So let's do some coding in our main function and see how it looks. So I would like you guys to type in whatever I have typed in. I have made two functions, which is true and false. So don't worry guys, I will go over functions in my future videos, but for now just understand this function's purpose is that it will print a statement which is true, and it will also return a true value over here. So for the function true, we'll get a return value of true, and the function will also print out true. Similarly, the false function will also have a return value of false, and also it will print out false statement. So in the main function, what we will do is we will declare a boolean type variable. Let's say it's res, and then what we can do is, let's say we assign res equal true A, let's say, or false B, and let's say we're comparing with true C. So let's see what happens over here. So if you look at this, by let's start with false. That way it will be much better to understand. So by truth value, if we have a false, then we will look to my right, then we will still have execution to my right. It will not have a short circuit. So if we have a false value, we will not have a short circuit evaluation. It will still look for the values in the right hand side, and then it will try to execute for the final result. So over here what's going to happen is that it will evaluate this, which will return false. So, and then it will look to its right hand side for a final result. So if it will have a true value, that's what it's trying to evaluate. So over here this and will take precedence. So what's going to happen is that over here the consideration will be like this, like it's taking it as a whole. So if there is a false, right, and then we have a comparison of and, so we know that if we have this evaluation is false, the first evaluation for and comparison is false, we don't need to do the second comparison. It will have a short circuit evaluation, because any comparison of false with and comparison is basically false according to the truth table. So as you can see over here, if we have a false value, then we have a short circuit evaluation. We don't need to evaluate the second value over here, right? Because if we have a false evaluation, if we have a false in the initial state, then the answer is directly false. So if we save this and if we print it, you will see that first we had an evaluation which is false, and then we have an OR, so it's looking for a true value if there is a true value in the right hand side, and then it went for this part, and over here the first evaluation is false and the comparison is and, so it will not evaluate this part. So as you can see, the evaluation for this part is false, which we got a false value here, and the evaluation of this part is false, which had a false value over here, and then it had a short circuit evaluation, so it never executed this state, this function. So as you can see, it directly gave a false result for this part, and false compared with false is false, which is stored in the res variable, and then it went to code number, and then it went to line number 55 and it printed that statement which is false. So as I told you, C++ represents false with 0, so it gave a statement of 0. We can actually make it a false statement by typing in bool alpha and then stream insertion operator. So save it. Hold on a second, let's see. Oh, I made a mistake over here, so that's LPHA. Okay, so save it. Now let's run it. So as you can see over here, first execution was false, and then the entire execution was false, and then we got our result, which is false, right? So what if we have true instead of false here? What do you think is going to happen? So what happens is over here is that, so this is an OR comparison, so we will have a short circuit evaluation. So if we have a true, the result is directly true, so that's going to happen. In this operation, this entire part will be short circuited. So after the evaluation of this, there is true, we don't need to evaluate anymore. So C++ will follow a short circuit evaluation. It will directly store a final result which is true in the res variable, and it will show us that result. So let's save it and let's run the code. So as you can see, the first evaluation was true, and then we had a short circuit evaluation, and the final result was true. So let's see another combination. So let's say we have a false here, we have a false here. Oh, actually no, let's say we had that variation. Let's say we have a true here, and let's take this off because it will happen automatically by default. So let's save this. Let's make this actually false. So let's save this and let's see what's gonna happen. So before I run the code, I will give you guys some time to think about what's gonna happen. See if you can actually understand the logic and try to try to actually compile in your mind and try to see if you can actually figure out what's going to happen in this, and try to figure out the answer by yourself before you run the code. That is how actually you can learn programming in a better sense. So yeah, go ahead and try to figure out in your mind before you run the code. I will give you some time. So I hope you guys actually give it a try, and and I don't know what you got the answer as, but before we run the code, let's go over it and let's see what's going to happen. So we have a false evaluation over here, and we have a OR comparison. So if I have a false, I need to see the right hand side if we have a true value. So we have a true value here, but as I told you, AND comparator actually have a precedence over OR, so it will take it as a whole. So everything has to be executed over here, right, as a whole. So we have a true, but then according to my truth table, even if we have a true value, we need to check the second value if it is again a true. So over here, this will be executed, and then this function will also be executed. So we'll have 3 statements, and then we'll have a final result. So this is false compared with true, and then this part is false. So basically this entire comparison will give us a false. So false or false will be a false. So there will be in total 4 statements. So let's run the code and let's see. So as you can see over here, we got a warning. So that's not an error, by the way. So the first part is a false, as I told you, this part. And then the second part is a true, because this part was true and it was compared with the AND operator. So that's why the third function was also executed, which is a false, and we got that print out statement here. And then the entire result was false, which was stored in the res variable, and then we executed line number 55, which had a bool alpha object, and it's telling us that okay, the entire result was false. So as you can see, this is how we use the logical operators. So now let's look at some negation. So let's comment these. Let's comment this line out, this one out, and also this. So let's do let's say boolean x equal true, and then we are trying to print out the negation of x, let's say, and then stream insertion operator will do not x, and then again an insertion operator, and then end L. Save it. Let's run this code. So as you can see, the negation was 0, which is the negation of true, which is false. So let's do so over here you can go again. So over here you can type again bool alpha, and then insertion operator, bool al. I always make that mistake. ALPHA, alpha. Okay, so save it, run the code. So as you can see over here, the negation is telling us it's false. So over here, if you have false, over here, if you have false, if you run the code, you'll get a true. So as you can see, we have a negation and it's giving us a true value. So now you can have more advanced combinations. So let's say if we have something like this, let's say we have bool y equal, so let's say we have something like this. Let's say we had true of A or true of B, and then we had a negation over here, and then we're trying to print out that over here. So what do you think is going to happen over here? What do you think is going to print out? So let's evaluate that before we run the code. So we have a true value over here, and it will be short circuit evaluation because this is the OR operator, so this will never be executed. So, and then the entire result is true, and then we had a negation which is false. So we will expect a false answer over here. So let's save it. Let's run the code. So as you can see over here, it's false. And also, as you can see, the first execution happened, which is true, and then we had a short circuit evaluation, so this was never executed. So if we had false here, and then let's save it. So first of all, we will have a false, so this will be evaluated, and this time there will be a short circuit evaluation, so this will be evaluated as well. We have a true, so the entire result is true, and then it had a negation, which is here, and then so true's negation is false, so we would expect another false value, but with two statements before that. So as you can see, the first statement here, the second statement here, and then the final result is false. So this is how you can use the logical operators. We'll also, in the future videos, we'll also see some more advanced concept of logical operators, because mostly logical operators are used in control flow, as I already mentioned. So there are more abstract way to use logical operators, and then you will write more algorithms with that. So this is how, so I hope you guys understand the basic concept of logical operators. So I would like you guys to play with logical operators more, try to read some more advanced concepts of logical operators by by understanding structure. So I would like you guys to go to Google and search for more conceptual questions regarding logical operators. You guys can look for structural mathematics using logical operators. There will be a lot of abstract math using logical operators, which you can try to solve it. Other than that, I would say try to have some fun writing some very simple codes using these logical operators. So that concludes this video. I hope you guys enjoyed it. See you guys in my next video. Thank you.